Okay, in the last video, we started mentioning a little bit about how the word public was important to give access. Now we're going to go a little bit about over what private is and why it should be used. There's a whole bunch of places where we want to use private data and other things that are private. So imagine that we have a program where we are going to be inflating and deflating some balloons. So we'll create three objects. We'll have three balloons. One will be a red balloon, which we're going to construct like this. So our red balloon is going to be a new balloon. And then we're also going to have a blue balloon and a green balloon. So we've got these set. And what I want to do is, you may remember from constructing the scanner object that we can send parameters. So what I want to do is I want to state what the initial volume of the balloon is going to be. So for the red balloon, I'm going to leave it as 1.1. For the blue balloon, 2.2, and then for the green balloon, 3.3. So this is going to be the initial volume of those balloons as we construct them. So now what we're going to do is we'll create the balloon class. So I'm going to make a new file, call it balloon.java. Okay, and this is where we're going to do this. Okay, so as we create the balloon class, we're going to start with the public, because again, we want our other class to be able to access it. Public class balloon. Okay, and in here, we've got our class members, which are again the data, and the class methods, which will be, of course, the actions. So we'll do a little bit more in this program. Class members, there we go. Oh, no, actually, it's only going to be one for this program. So the only thing that our balloons will know is they will know their volume. Okay, so that's going to be important here. Now, we'll go back to, well, let's make the constructor for it. Okay, so same way, public public balloon. So again, they just have the name of the class is the name of the method that constructs it. And what we're doing is we are sending to the constructor, we're sending a double value. So what we have to do is we have to make a double value parameter to receive it. So we'll do double, and very commonly I use just a single initial for the representation of what that is. So this is the volume. I want to call it V. I don't want to call it volume here because you can see that the class already has a volume value. So when we're constructing it, just like in the other program, we want to set what the initial value of the volume member is, and we're going to set it to V as opposed to like a specific value. Okay, so now I've got three balloons and I've got their volume set because of this. Okay, so now what I want to do is I want to be able to inflate these balloons and deflate the balloons. So here is a problem. So a standard balloon can have balloon has a volume from anywhere from 0, which means completely empty of air. Of course, you can't have negative volume in a balloon. You can't have a negative amount of air. All the way up to about 11 liters. So it goes from 0 liters to 11 liters. Now, Of course, it was not feasible. It's not possible or realistic to have less than 0. But also, if you exceed 11 liters of volume, what is very likely is that your balloon is going to pop. So what I want to do is I want to make sure in this program that the volume of the balloon never exceeds 11 liters. So I am typically, what you do is if you're working in a team situation, maybe you're responsible for creating the balloon class, you hand it off to somebody else. But what you don't want them to do is do something like this. So I want to do red.volume, and I want to make it equal to 20. Now, what happens here is the red balloon pops because its volume has exceeded the maximum volume for a balloon. So this is where we protect the data that is inside the classes. So if I run this, you're going to see it's not going to have a problem with this. I don't get an error. What I want to do is I want to prevent this. So nearly always, we take every single member that is inside our classes and we make them all private. So members are almost always private. I'm going to put that in capitals too. You'd actually have to come up with like a really legitimate reason why you don't want it private in order to remove this, because you want this class to have 100% control of all of its members. You don't want the main program or some other class to do something that the balloon class or like whatever it is won't expect. So here's what happens now. Run the program. And then you're going to see this. Error. Volume has private access in balloon. So it doesn't like this because the access to volume is private. So this is not acceptable anymore. So we're going to turn this into comment not allowed. So what we've got to do is, okay, all of a sudden, now we don't have access to the volume. We've got to figure out a way that we can inflate and deflate these balloons. And this is where the class methods come in. So what we're going to do is we're going to create one called inflate. So this is one of the actions or methods that the class will have. So public void inflate. These are very similar to other methods that you've programmed. So, and what we're going to do is it will receive a double value I. And let's just assume a non-negative entry to this thing. That way we don't have to program in an extra check. So what we want to do is we want to do volume becomes volume plus I. So we're going to pick the amount that it increases by, and then we are going to add that on. So if I go back to the main program, I can do something like this. So red.inflate 4. And let's inflate them all. We'll add 4 to the volume of each of our balloons. So red, blue, green. There we go. So we're going to inflate each one of these by 4. So now what I want to do is I want to display the volume here. So system.out.println, and I want to do the volume of red balloon plus red dot volume. Okay, so now again, this is a problem. So if I run the program, we're going to see the same thing happen. It says volume has private access in balloon, so I can't access the member directly. So just like we used this to control inflate, and we're going to add something that'll be further control to it in a minute, what we want to do is we want to only allow methods to control what the user is allowed to see. So instead of this, we're going to write a method called getVolume, or we're going to do getVol for short. So in Balloon, this one is going to be public. Now, this is going to act like a double here. So this is actually going to be a double method. And we'll have getVol. And all we have to do here is we have to return the volume. And that's it. So now, in our program, if I run this, we get the volume of the red balloon. So it's 1.1 plus 4. So let's set this for our other balloons. So do a copy paste. So we're going to do this for blue and green and blue and green. There we go. And then we'll get the volumes of all three. There we go. So that's a good start. Now what I want to do is we'll use this a little bit further. So we'll add an extra line. And then I'll use some combination here. So what I want to do is now I want to double the volume of each of these balloons. So the way that I would do this, it would be red dot inflate. Now I want it doubled, so here I'm going to need to know what the volume is. So I want to increase it by its own volume. So this would be written as red dot getVol. And then I'm going to do this for all of the balloons, doubling their size. So red, blue, green, and then we've got to do this, blue, green, and we'll put our little display thing here again. All right, so let's take a look at their volumes now. So you can see after the second inflation, 2 of the balloons went over the maximum. So this is where we're going to put the control into our balloon class. So I don't always want to increase this. I only want to increase it if there is, by this much, if there's enough room to do this. So here's how we're going to fix this. We're going to add in an if statement. So if the volume plus however much we're inflating is going to be larger than or equal to 11, then what we're going to do is we'll give them a warning. So system.out.println, let's say warning, balloon at 11 liters. And we'll just set the volume to 11. So that way we're not going to go over 11. We'll just assume we're stopping here. And we'll only add it on the regular way otherwise. So we'll do it like this. So now I'll go back to the main program and run it. And here's what we get. Now, the balloons are not self-aware of their own names. So there's no way, unless we add a string to them, that will store their name to say which balloon it is. But anyway, the balloon is full, and then we actually get to see which ones it is. So we'll do the same thing with a deflate, and then we'll control it in the other direction. So imagine that we wanted to, I'm going to deflate these balloons by 10.5. So deflate 10.5, deflate by 10.5. I just realized I can just switch the in to a D, 10.5, and I've got to write this method. So do inflate. I'm going to copy and paste and make a deflate. And now this one should be D. Now if the volume minus D is less than or equal to 0, I'm going to say warning balloon empty, and then I'll set the volume of it to 0, and otherwise I will do the volume is going to be the volume minus the amount that we're deflating. So back to the main program. Hopefully you're paying attention to these tabs and being able to follow where we are going with all of this. I am going to put a final volume display, and I'll run the program. And then we will get the one warning that a balloon is empty. The first one has become full. These are the same because they both maxed out at 11 in the previous step. So when you're writing classes, nearly every single time you're going to want to make their member data private, so that the main program or some other class or some class that somebody else writes doesn't have access to doing anything to it that you don't want. If you want to prevent something from happening, that is where you need to put in some if statements to make sure that the values don't change outside what you expect.